Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on antenna design. This video, I'm going to share with you how can we actually visualize the antenna performance using two different types of radiation pattern. The first one will be 3D radiation pattern. From this 3D configuration of antenna performance, we probably can extract very little information. For example, okay, if we want to know the gain, it may be very challenging to obtain the full coverage of the gain. However, this 3D radiation pattern will be very useful if we want to know how directive the antenna is. For example, when we actually have this antenna, we would like to know whether is it omnidirection or directive antenna. So therefore, this 3D radiation pattern will be very useful for us to see the radiation pattern of the antenna. As for the other type, 2D, there are actually two different types. One is the polar coordination system. Another one will be the Cartesian or coordination system. Okay, so this video, I will show the difference between these two types of 2D pattern cuts. So basically, this will be the objective of this video. Guys, if you're keen to know more about antenna design, please see the playlist under the description. Over there, you will be able to find a series of discussion on antenna design. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Just give me a few seconds. Press the like button now. For those who are new to this channel, and if you want to encourage me, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Let's quickly understand how can we actually visualize the antenna performance. So therefore, in order to know the antenna performance, engineer actually use this radiation pattern. From here, you can see that this is actually the 3D radiation pattern. This is actually the 2D radiation pattern. Basically, from this radiation pattern, they actually illustrate how an antenna directs or receives the radio energy. Let's take a look on this diagram. Okay, so basically imagine this is actually a transmitting antenna. So therefore, from this XYZ, we are able to see how the antenna actually release the electromagnetic wave. So basically this point here is exactly transformed into this point. So from here, you can see that this antenna is actually quite directive. Majority of the signal actually concentrate in the Z-axis. So basically, this is how we can make use of the radiation pattern in order to understand more regards on the antenna performance. While the 3D case sphere coordination system is the most complete representation, however, it is often simplified into 2D blocks. So basically, this is actually the most complete. Okay, so in fact, you have almost everything, but you can't get in detail, okay, all the reading over here. So therefore, in order to have more deep dive into the characteristics of the antenna, so therefore it is very common that we actually transform this 3D into 2D plot. So basically, this is what you want to say. Next, let's kickstart the 3D radiation pattern. Okay, so this is probably the most intuitive representation, okay, but can be complex to draw, and it is also very difficult to interpret. So from here, you can see that a lot of information can be available. However, in deep detail, we probably can't get it from this 3D radiation pattern. Let me explain. Okay, so a 3D dimension system where the distance from the origin, okay, so basically this is actually the antenna, okay, to the surface. For example, this is to the surface. Basically, this point here actually represent the radiation intensity in that particular direction, which is the Z-axis. So basically, this point here will be able to tell us the radiation intensity, how strong. Okay, basically from here you can see that this is probably the strongest point from the antenna. Okay, so basically this is when we want to use this 3D radiation pattern. So from this so-called graph here, we will be able to anticipate that this antenna is actually very directive. Okay, it's directive in the z-axis. Coming to the pro of this 3D radiation pattern, they actually give a complete holistic view of the antenna performance. So this is what I mean. So everything will be so-called available at one glance. It clearly shows the main loop. Okay, so basically this is actually the main loop, the side loop. Okay, so these are all the side loop and also the nulls in all direction. So basically these are all the nulls. So basically if you also want to know the main loop, the side loop and also the nulls, okay, at which direction you actually will be able to obtain from this 3D radiation pattern. Coming to the negative portion, okay, so the information can be very cluttered and it will be probably very difficult to extract precision numerical data from. Okay, so basically over here, let's say, okay, we can easily obtain the maximum radiation intensity, for example, for this case here. However, the rest of the information may be a little bit challenging for us to extract. So therefore, because of this, this is actually not ideal for technical report or data sheet where specific cuts are very important. So basically, in short, let me do a quick conclusion. From here, we probably can see how directive the antenna is. However, in order to extract the very precision numerical performance, it may be very challenging. So therefore, we actually transform the 3D into 2D pattern card. Okay, so there are actually two types. Let's come to the polar coordination system first. Okay, so in fact, this is the most common and standard way to present antenna performance in technical data sheet. Okay, so it take a slice through the 3D pattern. I come to this slice on my next slide. Okay, I will explain this. But over here, as you can see from here, okay, so basically this is most of the time when you want to purchase an antenna, okay, they actually will provide this. So once glance, you can see that this antenna actually radiate at particular so-called direction, and you probably can also understand that the gain they actually provide. Okay, so what is all this about? So basically, this is actually a two-dimension plot on a polar grid. Okay, so basically, polar grid means that it's basically in degree over here, as you can see from here. The angle, okay, the beta or the alpha, the beta or the gamma is basically the direction, and the distance from the origin is the radiation strength, usually in dB. Okay, so basically, this graph basically was mentioned that they are either the beta or gamma. And basically from here, you will be able to know the gain at a certain so-called direction. Okay, so in short, this polar plot, okay, so basically these are all the polar plot. They actually shows how gain change with angle. So from here, you can see that how the gain actually change with angle. Okay, so basically this is a quick so-called definition of 2D pattern cuts with polar coordination system. Coming to the pro, what will be the advantages? This is very clear for visualize beam width. Okay, so basically you can see that this is actually the beam width. Okay, and how directive it is, and also you probably can also see the side loop level. Okay, so basically these are all the side loop level. So as you can see that this can be easily quantified. So this is also very intrusive for understanding the angular coverage. Okay, you can see that which angle they probably can cover. Okay, so basically this will be the advantages of the antenna radiation pattern from a 2D pattern card with polar coordination system. Coming to the disadvantage, okay, so it actually require at least two plot. Okay, so later on I will show you these two plot. The E plane and H plane, sometimes is also known as the azimuth and elevated plane. Okay, in order for us to fully categorize the antenna. Okay, so the logarithm scale can compress the plot, make low-level side loop hard to see. Okay, which means that, for example, there is some form of side loop which are not possible for us to visualize when we actually use this 2D pattern card with the polar coordination system. Let me come into more detail in terms of the cards. Okay, so there are actually two common cards. One is called the azimuth plane. Okay, so another one is called the elevation plane. Okay, so basically this is actually the 3D radiation pattern from the antenna. Okay, so basically this is basically the so-called the XYZ plane over here. So what is actually the azimuth plane? Okay, so azimuth plane is actually the horizontal slice showing the pattern above the horizon. Okay, so basically imagine this, you just cut in this direction, just cut in this direction. Okay, so basically you will have this azimuth plane. Okay, so basically you will be able to extract more information from here. Okay, so this is what we know as the common cut azimuth plane or the H plane. Next will be the elevation plane, okay, which is also known as the E plane. This will be a vertical slice showing the pattern above and below the horizon. So basically this will be cut, okay, at the y-axis from here. So therefore, you can actually get this elevation plane from this here. Again, from here, you will be able to see more information regards on the radiation pattern of the antenna. So basically, this is actually the 2D pattern cuts in terms of the polar coordination system. Next, I will show you more information. So for example, you can have more information, okay, on this 2D elevation plane cut. Okay, so basically this is for the polar coordination system. However, there will be a major issue. For example, you can see that, let's say I want to have 20 degree, okay, how much will be the gain? For example, I may not be able to extract the information. So this is actually the potential problem of this polar coordination system. Let's say I want to have more detail. Okay, so basically based on the polar value here, I will not be able to extract the exact, let's say 20 degree. I will not have this information. So therefore, in order to have a full, complete, so-called 2D pattern cut, then we have this so-called Cartesian coordination system. Okay, so guys, before I continue, urge you, if you have learned something from this video, help me by like this video. Guys, just give me a few seconds. Help me press the like button now. Again, if you have learned something from this video and if you appreciate this video, help me by subscribing to this channel and turn on your notification bell. Let's come to the Cartesian coordination system. Remember, okay, Cartesian coordination system will allow us to have more insight. For example, as I mentioned over here, for the polar coordination system, we probably very difficult for us to extract more information. For example, 20 degree. So therefore, the Cartesian coordination system will allow us to have all information. Let's take a look here. So basically, this diagram here actually shows the Cartesian coordination system. Okay, you can see from here, whatever the degree, you will be able to see the gain, for example, for this case here. Okay, so basically, this is actually the 2D pattern cuts based on the Cartesian coordination system. This is, in fact, a very powerful alternative to the polar plot. The price, okay, is basically the precision. So basically what it is, okay, so basically it's a standard XY graph. Okay, so you probably know the X and the Y graph. So the X-axis typically is the angle, okay, from minus 180 degree to 180 degree. As for the Y-axis, okay, most of the time, it can be the power, it can be the gain, etc. So typically, most of the time, they are always in dB. Okay, so basically, this is how we can actually quantify the radiation pattern of the antenna. Next, we come to the key characteristics. Okay, so we talk about the linear angular scale. Okay, so basically you can see that you roughly have some estimation. Okay, so even with certain precision, okay, in between the gap here, we are able to know, for example, the power level. Okay, so basically, this is basically the advantage. So the angle are spaced evenly, unlike the polar plots where they are radiant. As for the logarithm power scale, okay, so this is actually very critical. From here, you can see that you are able to see very low side loop, even as low as minus 30 dB, you will be able to see from this plot here. Okay, so most of the time, okay, the main loop basically will be have a reference of 0. Okay, so basically the flat bottom of the plots correspond to a very weak radiation. Okay, so therefore, this Cartesian coordination system, okay, will be very precise. Okay, based on the angle, okay, you will be able to know the precise so-called radiation power, for example, or even the gain of the antenna. Okay, coming to the Cartesian coordination system, coming to the pro and also the con. Okay, so we are going to have excellent dynamic range, okay, from the highest point to the lowest point. For example, here, the highest point, okay, up to the lowest point, we will be able to see at one glance based on this Cartesian coordination system. Okay, so it is the best format for accurate reading and comparing very low side loop level and deep nulls. Precision, okay, so it is much easier to read exact numerical value for bin width, null depth, and also the side loop level directly from the axis. Okay, so it is also very easier to plot. Okay, so basically the standard graphing tools can easily generate all this information. Coming to the negative portion, okay, so basically it is less information. Okay, so the direct visual connection between the shape of the graph and the physical direction of the radiation is lost. A loop look like a pit, not a loop pointing in a direction. Okay, so for example, from this graph here, you probably cannot tell which direction they are actually point at. Okay, you lost the information, or for example, you were probably not able to tell how directive this antenna is. Basically, this is the so-called limitation when you actually under this 2D pattern cut with the Cartesian coordination system here. Okay, so coming to the negative, this is what I mentioned here. The direct vision connection, okay, which I mentioned here, you probably won't have a lot of information. They can be less immediately understandable for a quick visual assessment of antenna coverage. Okay, so coming to my last slide, okay, so basically I put everything, okay, in a table for you to understand. So this is actually the 3D, this is the 2D polar, this is the 2D Cartesian plot. Okay, so basically most of the time for 3D, okay, it look like a sphere. For 2D, basically will be a polar. For 2D Cartesian will be a Cartesian format. So this is actually best when we actually want to have some form of concept understanding how so-called directive the antenna is, etc. So basically, we have this complete visualized, but it is always very difficult for us to quantify a very accurate reading. Okay, basically all the information are all cluttered. As for 2D polar plots, it is actually most of the time available in all the standard data sheet of the antenna. Basically, we have very intuitive angular view. Okay, however, we may need to have multiple plots in order to have the full understanding of the antenna performance. Next will be on the 2D Cartesian plots here. So this key advantage, it actually gives high precision in terms of the so-called the gain in terms of the radiation energy, etc. So if you need to have all this precise information, you probably can only see these 2D Cartesian plots here. So this is what I mean. And also, we probably can have very accurate reading. Okay, even this side loop on now, they are actually very small. We are able to look at all this information. However, it is less intrusive in terms of the shape. Basically, you will not be able to know how, for example, which angle that is actually covered. For example, for this case here, you won't have this idea here. So basically, for this video, I have covered the 3D radiation pattern, the 2D for polar, and also the Cartesian plots here. But over here, you can see that we have another two different plot. One is the isometric view and also the rectangular plot. We also have the split chart, which able to tell how good the matching the antenna is. With this, I like to end my discussion. Okay, probably my next video, I will explain a little bit more in terms of the antenna radiation pattern. With this, that's all I have for you for this video. Thank you so much for strong support. Okay, so remember, okay, help me to press the like button and also consider to subscribe to this channel. Once again, thank you so much. I hope to see you guys soon. Bye for now. Thank you so much.